So continuing on these little horizontal problems, this is just great stuff. I can't believe all this great practice you're getting. So there's two ways to actually do this. One is to try to solve the problems, and the other is to just go with my video solutions. And I'll tell you right now, if you're just looking at my solutions and sort of praying that you'll absorb it by osmosis, and you're not writing, you're really in bad shape. If you're writing my video solutions and you're actually following and writing it down, you may be in better shape. But really the best way to try to do this is to kind of rack your brains and really try to get this, and then sort of give up and use the video solutions as the last resort. That's when you'll really be doing well. So again, if you get a lower grade on the exam and it's because you could only look at my video solutions, and get the answers, that's sort of part of getting that struggle to really learn it on your own is really what we're getting at here. And I know we're not completely there yet, but we're going to get there. So we have this bird, and he wants to, I guess, poop on this guy's head. And we have to figure out the distance that the bird must actually poop from in order to get this guy. So here's the deal. We know x naught is 0. We don't know what x final is. We know that y naught is 10 meters. And we know that y is, we're going to call this 0. Okay? So we're going to define the top of the waiter's head as 0. And now we want to solve some things. So first, let's get the time it takes the dropping to fall. So we're going to get y equals 1/2 negative 1/2 gt squared plus v naught yt plus y naught. This seems to be like the first equation that we pull out a lot of the time. And so we're just going to not fight it and just do the same thing. So with that in mind, what we're going to do is go ahead and plug in our numbers. So y equals negative 1/2 times 9.8 times t squared plus 0, because our speed, this is v naught x, right, plus 0, or actually plus 10. So you have negative 10 equals negative 4.9 t squared, and so we have, when we actually do that math, it's 10 divided by 4.9, that's t squared. We take the square root, and of course we end up getting a time of 1.43 seconds. And of course we're neglecting air resistance. I think with real birds and real poop, you have to actually take air resistance. Whoops, sorry about that. You actually have to take air resistance into account. So we'll go ahead and do that. Without air resistance, of course, and we'll just go ahead and solve that. So when we get that, that ends up being x equals v naught xt plus x naught, and so we just plug in x equals 20 times 1.43 plus 0, and that's pretty much it. We're going to end up getting, so 1.43 times 20, that's 0.682, 2 decimal points. So x is 28.6 meters away. So that's pretty much it for that one. This is just good stuff. So now moving on to the next page. I don't know when this was written. Probably a while. So, but we're just going to go ahead and just kind of do what it says. So here we finally can start using our easier formula. So let's go ahead, flip this back, and do problem 14 using the formulas that we always know. So here, for number 14, we actually have a formula. So for 14, how long is the ball in the air? We want to get the hang time, and we want to get the range and the maximum height. So let's just use our formulas. We've got 20 at 60 degrees, so this is so nice for us. We have the hang time is going to be 2 v naught sine theta over g. So that's going to be 2 times 20 times the sine of 60 divided by 9.8. So this is just wonderful. So it's 40 times, this is just great. And I'm getting a hang time of 3.53 seconds. And then we're going to end up getting a range of v naught squared sine of 2 theta divided by g. So let's just plug that in. So that's going to end up being 20 times the sine of 120 degrees divided by 9.8. So that's 20 squared. So let's get that range. So that's going to be, when we actually do that calculation, we'll end up getting 400 times the sine of 120 divided by 9.8. And just double check, I actually am getting 35.35 meters. And then to get the height, that's going to end up being v naught sine theta, all of that squared, divided by 2 times 9.8. Now, for those of you that know trig, I'm actually going to do this by hand. So it's going to be 400, and that's going to be radical 3 over 2 quantity squared divided by 9.8. And I'm going to do a little rounding here. So this is going to be 400 times 3/4, all of that over 10. I'm rounding here. So this ends up being 100 times 3 divided by 10. So I'm getting about 30 meters. So that's problem 14. Wow, now this one is actually really good. So this is good. So so let's see where we're at with number 15. So just highlight this and delete it, and I'll move on to number 15. So problem 15, just going to be a little trickier idea. Again, it's just the same thing here where, unfortunately, we have a building. So this thing's being launched in the air, and then it's landing. And it's not that perfect projectile motion, so we can't use these range and height and whatever equations that solve for everything. We actually have to do it kind of the old-fashioned way. So here's the deal. We have x equals v naught xt plus x naught. We have y equals negative 1/2 gt squared plus v naught yt plus y naught. And there's two other y equations, but I want to see if we can get away with using just these, and we'll bring in the other equations later. So we know, actually I'll write them down though. So vy squared equals v naught y squared plus 2gy minus y naught. Actually, it's minus 2gy minus y naught. And we have vy equals negative gt plus vy naught. So hopefully just going through this packet, you're memorizing a lot of these. Now, here, let's get the horizontal distance the ball travels. So we're told that it starts off at x naught equals 0, and we're told that it travels for 2.5 seconds before it reaches the top of the building. So let's go ahead and get that. So x equals v naught xt plus x naught. Now, to get v naught x and v naught y, let's remember that v naught x is 22.5 times the sine of 45, and v naught y is 22.5 times the cosine of 45 in the x, and it's the sine of 45 in the y. So I just made the classic mistake. So please be careful with that. So when we do that, 22.5 times the cosine of 45 works out to 15.91 meters per second. When we do the calculation for 22.5 times the sine of y, we also get 15.91 meters per second. And now we can go solve some stuff. So we have x equals 15.91 times t, which is 2.5 plus 0. So let's go ahead and get that. And we actually end up getting x is 39.77 meters. Now for the y direction, let's get the height. The height is how high the ball goes, so that's y equals negative 1/2 times 4.9, times 9.8. I keep doing that. negative 1/2 times 9.8 times t squared, which ends up being 2.5 squared, plus, because this is going upwards, this is going to be plus 15.9 times 2.5 plus 0. So now we can get our height. And when we actually solve for that, let's go ahead and get that. So negative 4.9, because that's 1/2 times 9.8, times 2.5 squared. All right, plus and I'm getting 9.125 meters. But I'm just going to double check that because I'm going to make absolutely sure I got this right. So that's 4.5 squared. So times 2.5 squared. That plus it's about 9.125 meters. You might have got like 9.1 or 9.2. Both of those are totally fine, so it looks like we got that height perfectly. See if we can try to do one more. So you know what? We're actually going to hold off, and we'll take up the next couple problems in the next video.